Our solar system is a place of wonder, filled with celestial objects that spark our curiosity. Among them is Mercury, the smallest planet and the closest to the Sun. Mercury's swift journey across the sky, visible only near sunrise and sunset, earned it the name of the messenger god in Roman mythology. Like a moth drawn to a flame, Mercury orbits the Sun at an astonishing speed, completing a single orbit in just 88 Earth days. This swift journey, coupled with its slow rotation, creates extreme temperature variations on its surface, ranging from scorching heat to frigid cold. Beneath this harsh exterior lies a fascinating world of towering cliffs, vast plains, and evidence of ancient volcanic activity. Imagine a celestial dance floor where planets waltz around a radiant star. In this grand cosmic ballet, Mercury takes center stage, its movements a testament to the powerful forces at play in our solar system. Mercury's day is a curious phenomenon, lasting almost twice as long as its year. This unusual relationship between Mercury's rotation and orbit creates a unique situation where the Sun appears to move backward in the sky at certain times. Imagine witnessing such a sight, the Sun rising in the east, pausing and then retreating back towards the horizon. These subtle tugs and nudges, occurring over millions of years, have shaped Mercury's orbit into the unique path it follows today. The surface of Mercury is a testament to its tumultuous past. Battered and scarred by countless impacts from asteroids and comets, it paints a picture of a planet that has endured the relentless bombardment of space debris over billions of years. One of the most striking features of Mercury is its abundance of craters, some of which are hundreds of kilometers in diameter. These craters, some ancient and others relatively young, provide a window into the early solar system, a time when collisions were far more frequent. Beneath its heavily cratered surface, Mercury harbors a surprising secret, a massive iron core. This core, disproportionately large compared to its overall size, is a key to understanding Mercury's formation and evolution. In the grand cosmic ballet of our solar system, each planet performs its own unique dance around the Sun. Mercury, the smallest and swiftest of them all, takes center stage with its eccentric and rapid orbit. Unlike the more circular paths of its planetary siblings, Mercury's journey traces an elongated ellipse, drawing it closer to the Sun than any other planet. Its orbital speed, averaging a breathtaking 47 kilometers per second, is a testament to the Sun's powerful pull. This elliptical path, with its varying distance from the Sun, plays a crucial role in shaping Mercury's unique environment, influencing its temperature extremes and the length of its days and nights. As we continue to marvel at Mercury's celestial performance, one cannot help but be astonished by the sheer speed at which it completes its orbit around the Sun. A year on Mercury, the time it takes to complete one full revolution, is a fleeting 88 Earth days. This rapid orbital period has earned Mercury the nickname the Messenger in Roman mythology, fittingly named after the fleet-footed god who carried messages between the gods. Mercury's swift journey around the Sun exposes it to intense solar radiation and a constant barrage of solar wind, a stream of charged particles emanating from the Sun. This harsh environment has shaped Mercury's surface over billions of years, stripping away its atmosphere and leaving behind a barren, cratered landscape. Despite the challenges of its swift orbit, Mercury's rapid journey around the Sun provides us with a unique opportunity to study the dynamics of planetary motion and the effects of extreme solar radiation on planetary bodies. While Mercury's orbit is primarily governed by the Sun's immense gravitational pull, it's not alone in its celestial neighborhood. The gravitational influence of other planets in our solar system, particularly Venus and Earth, adds subtle nuances to Mercury's orbital dance. These interactions, though subtle compared to the Sun's dominant force, can cause slight variations in Mercury's orbital path over long periods, like gentle nudges that shape its trajectory over millions of years. These gravitational interactions are not limited to simply altering Mercury's orbital path. They also play a role in influencing Mercury's rotation, causing a phenomenon known as orbital resonance. This intricate interplay of gravitational forces highlights the interconnectedness of our solar system, where even the smallest nudges can have profound effects on the movements of celestial bodies. In contrast to its swift orbital journey, Mercury's rotation on its axis is surprisingly slow. A single rotation, or a day on Mercury, takes a leisurely 59 Earth days. This means that a day on Mercury is actually longer than its year, a phenomenon unique in our solar system. This slow rotation, combined with its eccentric orbit, results in extreme temperature variations on Mercury's surface. It's a reminder that the universe is full of surprises, and even the most familiar concepts, like a day and a year, can take on entirely new meanings in the vast expanse of space. Mercury's close relationship with the Sun dominates its every feature. During its long day, the Sun bakes one side for over 2 Earth months straight. The surface hits a brutal 800 degrees Fahrenheit, hot enough to turn pizza into a molten pool. But here's the twist. Mercury barely has any atmosphere to trap that heat. So when night falls, also lasting over 2 Earth months, the surface radiates its heat away into space. Temperatures plummet to -290 Fahrenheit, colder than anywhere on Earth, even Antarctica in midwinter. This extreme temperature swing influences everything on Mercury, from the way its surface features form to the very possibility of finding any trace of water ice hiding in permanently shadowed craters at its poles. We on Earth take our atmosphere for granted. Poor Mercury has almost none, just a wisp of what scientists call an exosphere. It's more like scattered atoms than a proper blanket. How did Mercury lose its air? Blame the sun again. Its intense heat and the constant barrage of the solar wind, a stream of charged particles, literally blasted most of Mercury's early atmosphere away into space. This lack of air contributes to Mercury's extreme temperature swings. If Mercury were a Hollywood starlet, it'd sue for better lighting. The images we have from spacecraft reveal a surface as battered and pockmarked as a retired boxer's face. Craters dominate the landscape, evidence of billions of years of impacts with asteroids and comets. Some are huge, like the Caloris Basin, spanning nearly 1,500 kilometers across. Exploring this battered yet strangely beautiful landscape is like taking a trip back in time to the early solar system, providing clues about planetary formation and the violent processes that shaped our cosmic neighborhood. Craters are the most prominent feature on Mercury, a testament to its long and violent history. Imagine a cosmic shooting gallery with asteroids and comets constantly whizzing by, some scoring direct hits on Mercury's surface. The result? A landscape pockmarked with craters of all shapes and sizes, some so large they dwarf entire countries on Earth. By studying their size, shape, and distribution, scientists can piece together a history of impacts, revealing clues about the early solar system when collisions were far more frequent. Some craters, like the colossal Caloris Basin, tell tales of cataclysmic events. Each crater, a unique scar on Mercury's surface, contributes to a richer understanding of its long and storied past. While craters dominate Mercury's landscape, smoother regions known as volcanic plains tell a different story. Imagine a time when Mercury was a fiery, geologically active world, its surface ablaze with volcanic eruptions. These eruptions spewed forth vast quantities of lava which flowed across the landscape, filling in craters and creating the smooth plains we see today. These volcanic plains, often found surrounding large impact basins, provide evidence that Mercury was not always a cold, dead world. They offer a glimpse into a time when Mercury was a more Earth-like world, at least in terms of its internal heat and geological activity. As Mercury's fiery interior cooled and contracted over billions of years, its surface began to wrinkle and crack like a drying apple. This global contraction formed giant cliffs known as scarps, some stretching for hundreds of kilometers. The Great Valley is a colossal rift valley discovered in 2016 using NASA's MESSENGER data. Imagine a canyon stretching from New York City to Los Angeles, its cliffs towering kilometers high. These scarps record Mercury's evolution from a hot, active world to the cold, cratered planet we see today. A Mariner 10, a fleeting glance. For centuries, Mercury was little more than a blurry dot through Earth-based telescopes, its proximity to the Sun making it difficult to observe. Then, in 1974, came Mariner 10, our first emissary to this enigmatic world. While it wasn't a dedicated Mercury mission, Mariner 10 provided our first tantalizing close-ups during 3 flybys. Imagine the excitement in mission control as blurry images resolved into sharp details of Mercury's cratered surface. It was like seeing a familiar face for the first time, revealing features no one had imagined. Mariner 10's instruments confirmed the extreme temperatures, mapped nearly half the surface, and made a surprising discovery. Mercury has a magnetic field. Though weak compared to Earth's, this finding hinted at a more complex interior than previously thought. However, Mariner 10's flybys were brief encounters, like a tourist snapping photos on a whirlwind tour. It left us wanting more, with questions about Mercury's composition, its geological history, and that mysterious magnetic field lingering in the air. In 2011, after a journey of over 6 years and numerous gravity assists from other planets, NASA's Messenger spacecraft entered orbit around Mercury, becoming its first artificial satellite. This marked a new era in our exploration of the innermost planet. Messenger, short for Mercury surface, space environment, geochemistry and ranging, was no mere flyby tourist. It was equipped with a suite of sophisticated instruments, ready to unlock Mercury's deepest secrets during its year-long primary mission, which was later extended. And unlock them it did. Messenger mapped Mercury's entire surface in unprecedented detail, revealing the full extent of its cratered terrain, vast volcanic plains and towering scarps. It confirmed the presence of water ice lurking in permanently shadowed craters at the poles, a discovery with implications for the potential for life elsewhere in the solar system. The spacecraft also studied Mercury's tenuous atmosphere, analyzed its magnetic field in detail, and even provided insights into its internal structure, confirming its large, iron-rich core. Messenger's data revolutionized our understanding of Mercury, transforming it from a blurry dot into a dynamic world with a rich and complex history. While Messenger answered many questions, it also raised new ones, as any good scientific endeavor should. To build upon its legacy, the European Space Agency and the Japan Aerospace Exploration Agency teamed up to send Bepi Colombo, a 2-spacecraft mission to Mercury. Launched in 2018, Bepi Colombo is on a complex journey, using gravity assists from Earth, Venus, and even Mercury itself to fine-tune its orbit. It's expected to arrive at Mercury in late 2025, where it will split into 2 orbiters, the Mercury Planetary Orbiter and the Mercury Magnetospheric Orbiter. Bepi Colombo is like the sequel to a blockbuster movie, promising even more thrills and discoveries. It will study Mercury's interior in greater detail, map its surface composition with higher resolution, and investigate the planet's mysterious magnetic field and its interaction with the solar wind. The mission will also explore Mercury's unique environment, searching for clues about the planet's formation and evolution. Bepi Colombo is poised to write a new chapter in our understanding of this enigmatic world, delving deeper into its mysteries and revealing even more surprises. We've journeyed from Mercury's sun-baked surface to the depths of its iron heart, uncovering secrets hidden for billions of years. This tiny world, often overlooked in the grand scheme of the solar system, has proven to be a treasure trove of scientific insights. It challenges our assumptions about what a planet can be, reminding us that the universe is full of surprises. Mercury's extreme environment, a testament to its proximity to the Sun, provides a natural laboratory for studying the effects of gravity, radiation, and the solar wind on planetary bodies. By understanding how Mercury has withstood these harsh conditions, we gain valuable knowledge that can be applied to the study of exoplanets, the discovery of water ice in Mercury's polar craters, hints at finding this resource in unexpected places throughout our solar system and beyond. This finding fuels our search for life beyond Earth and expands the potential for future human exploration. And let's not forget the sheer audacity of the missions that have ventured to this unforgiving world. Mariner 10's fleeting glimpse Messenger's orbital dance, and Bepi Colombo's upcoming rendezvous all demonstrate the ingenuity and determination of scientists and engineers to explore the unknown, pushing the boundaries of human knowledge and capability. Mercury's story is far from over. It continues to beckon us, offering more secrets to unravel and deeper mysteries to explore. By studying Mercury, we gain insights into our own planet and the solar system's formation. Its magnetic field helps us understand Earth's protective shield. Analyzing its surface reveals the building blocks of planets. Studying its interaction with solar wind informs us about space weather. Mercury, the swift messenger, reminds us of the interconnectedness of our cosmic neighborhood. Exploration is about delving into the mysteries of our cosmic backyard. Here we find profound answers about the universe and our place within it. So, when you gaze at the night sky, remember Mercury, the tiny world closest to the sun, a testament to the wonders that await those who dare to explore the unknown. Its story inspires us to reach for the stars.